Hi Algebra 1, you should have this paper in front of you right now. So we're just going to review what we talked about yesterday, which was substitution. That was our second way to solve a system. So we're going to learn 3 ways. We're going to review substitution a little bit because it's definitely trickier than graphing. And then I will teach you the last way next week. So here's just some review steps that we did cover. We just kind of called them, we didn't look at them like a step-by-step process. So that's what this review sheet is going to show you to do. So the first thing that we have to do when we're solving for substitution is we've got to solve for one variable in at least one of the equations. It doesn't matter which variable we solve for as long as we have something by itself. Okay, so most of the time it's going to be x and y. So you want one of your equations to say x equals or y equals by itself. Sometimes they're going to give that to you already. Sometimes you're going to have to make it be that way. So that is our first step. And then our second step is with that information, we're going to substitute the expression that we make. Substitute. That we solved for in step 1 into the other equation. Don't put it into the same equation, put it into the other equation. When you do that, you should have one equation with one variable in it because you replaced one of the variables with the other one. And when I have one equation with one variable, I can solve it. So step 3 is I'm going to solve that new equation to get the value of the first variable. And again, it doesn't matter which one you solve for. It doesn't matter which one you do first. You might do it different than the person next to you and get the same thing. That's fine, as long as you're following these steps and doing everything legally. So that's going to give us one of our variables, x or y, one of them. So step 4 is we're going to substitute that x or y, the value that we find, into one of the original equations. Not your new equation, into one of the original equations. Because your new equation, we got rid of the variable we want now. And then we're going to solve it. So for example, if I solved for x, I'm going to take that x and plug it into one of my original equations. Because it's a system, I'm going to get the same thing. If I don't, something's wrong. So you should get the same thing no matter which one you use. And then all that's left to do, because you found your first variable in step 3, your second variable in step 4. So step 5 is just to write your answer. And we write it as an ordered pair, x, y, like this. Okay, so your answer should look like x, comma, y. Okay, make sure you've got all those filled in. Go ahead and go to that next slide or page in your packet there. And we're just going to look at some examples and go through them using the step-by-step thing that we just did. So example 1, it says solve the system of equations below by substitution. So step 1 was that I need to make one of these say x equals or y equals and get it by itself. Yes, they did already do that for me. So step 1 is done. I only need one of the equations to look like that. In this case, both of them do. That's fine. But what I'm going to do is I'm going to take this first 5x here, and because that's equal to y, that means it's going to be equal to this y as well. So I'm going to take that in step 2, and I'm going to plug it in for this y, leaving me with, instead of y equals 2x plus 3, I've got 5x equals 2x plus 3, because those are equal to each other. Okay, and then I'm able to solve, because now I just have an equation right here in step 3. I have an equation with one variable, so I can solve for that variable. 5x and 2x are like terms, so I need them to be together. So what they did is they took 2x and they moved it to the left side of the equation, making it minus 2x. They've got the minus already here. 5x minus 2x is 3x. Meaning when I divide by 3, I'm going to get x equals 1. So there's half my answer. Down here in step 5, I'm going to go ahead and fill in that x is 1. And then for step 4, I said you can pick either equation. They picked the first one because it's the easiest. It's got the least amount of things in it. So if I plug in my 1 here for x, y is just equal to 5 times 1, which is 5. So there's my other half of my answer. If I would have used this equation instead and plugged in 1, I would have got 2 times 1 plus 3, which is also 5. So it truly doesn't matter which one you use. Just pick the one that looks easiest to you. Okay, that was example 1. Now we're looking at example 2. Okay, example 2, step 1 is not done because I don't have one of these with the variable by itself. It looks pretty close. I've got one that says y minus 2x equals 1, and I've got one that says x minus y equals 4. So both of them are very, very close. I could put any of those variables by itself that I wanted to. This y is going to be really easy to get by itself, and this x is going to be really easy to get by itself. So you could pick whichever one you want. I'm going to go with what they did on the paper, of course, and they got this y by itself. So they moved this minus 2x across the equal sign, which means it becomes plus 2x. And now I have these two new equations, y equals 1 plus 2x, that's the one I just made. And then x minus y equals 4 is the same one from up here. Okay, so step 2 was to take that thing that you let be by itself, which is y, and take the expression that's equal to y, which is this one that's circled right here, and plug it into the other equation for y. So I'm going to take this y and replace the y in the other equation. So they just rewrote this equation, x minus, instead of y, I'm going to put 1 plus 2x, because that's equal to y, and then equals 4. So most of this stuff is just dropped down, then they replaced y with 1 plus 2x. Now, I'm very glad they did this example because this subtraction here is super important, because I am subtracting y, which means I'm subtracting this whole thing right here. All of this, not just the 1, not just the 2x, I'm subtracting all of it. So I do have to distribute that minus, making this a minus 1 and a minus 2x. Okay, next page, I'm going to switch screens here. Then I can combine my like terms. If I've got 1x here minus 2x, that's negative 1x, or just negative x if you prefer that. And then also my -1 and my 4 are like terms, but they're on opposite sides. So I've got to move this -1 over, and it becomes +1. And 4 plus 1 is 5. So I'm almost finished. -1x is equal to 5, so I'm going to divide both sides by -1 and get that x is -5. That's going to go in my first box. And now to get my y, I just pick either one of the first equations. Okay, they're using this one. It doesn't matter which one you use, and you're going to plug in your x. So if I do that, I've got 1 plus 2 times -5. 2 times -5 is -10. Plus 1 is -9. So there's my y. So this is my answer, -5, -9. That means if I graphed those two lines, they would intersect at -5, -9. Alright, so now you've got these 10 practice problems. You're going to do those on notebook paper. You can write your answers as ordered pairs on this page right here and just show your work on notebook paper and then staple it all together and put it in my basket. Let me know if you have any questions. Have a great day.